Elementary Science Class 7. Heat. Hot and cold. In our daily lives, we come across many objects that are either hot or cold. For example, tea is hot, and ice is cold.
Oh, I see. Can you give me some more examples of hot and cold objects?
Certainly. Let's make a list of some common objects and categorize them as hot or cold.
Okay, that sounds like a good idea. What kind of objects should we include?
We can include things like stoves, refrigerators, cups, and even our own bodies. Some objects are hotter than others, and some are colder than others.
How do we know which object is hotter or colder than the other?
Well, we often use our sense of touch to determine if an object is hot or cold. However, our sense of touch can sometimes be unreliable.
Really? How can that be?
Let's do an experiment to show you. I have 3 containers with different water temperatures. You'll put your hands in them and see what happens.
Okay, let's do it.
Great. After the experiment, we'll discuss why our sense of touch can be deceiving, and how we can use a thermometer to accurately measure temperature. Reading a thermometer. Today, I'm going to teach you how to read a thermometer.
Okay, I'm ready to learn.
First, let's look at the thermometer. You'll see bigger marks that
And
indicate
smaller
the
marks
temperature
in
between
difference.
them.
I see. So what do the smaller marks mean?
The smaller marks represent 0.2 degrees Celsius. So, if the bigger marks are 1 degree apart, there are 5 smaller divisions in between.
I understand now. That's really helpful to know.
Great. Now, before we use the thermometer, it's important to wash it with an antiseptic solution and give it a few jerks to bring the mercury level down.
Why do we need to do that?
It's to ensure the thermometer is properly calibrated and ready to give an accurate reading.
Okay, got it. So, how do we actually take a temperature reading?
Place the bulb of the thermometer under your tongue and hold it there for 1 minute. Then, take it out and note the reading. Laboratory thermometer. We use a special kind of thermometer called a laboratory thermometer. This thermometer can measure temperatures from -10 degrees Celsius to 110 degrees Celsius.
Wow, that's a wide range. How do we use this thermometer?
Okay, let's try an activity. Take some tap water in a beaker or mug, and dip the thermometer in the water, making sure the bulb is fully submerged but not touching the sides or bottom.
Got it. And then what do I do?
Hold the thermometer vertically and wait until the mercury thread becomes steady. Then, note the reading, that's the temperature of the water. Transfer of heat. Heat can be transferred through conduction, convection, and radiation. Let's start with conduction.
Conduction. How does that work?
Conduction is the process where heat flows from a hotter object to a colder object, like when a metal rod is heated at one end and the heat travels to the other end.
I see. So not all materials conduct heat the same way?
Exactly. Some materials, like metals, are good conductors of heat, while others, like plastic and wood, are poor conductors or insulators.
Interesting. What about convection?
Convection is the transfer of heat through the movement of a fluid, like water or air. When water is heated, the hot water rises, and the cooler water moves in to replace it.
I think I understand now. And what about radiation?
Radiation is the transfer of heat through electromagnetic waves, like the heat we feel from the sun. This doesn't require any physical medium to transfer the heat. Now let's light a candle. Keep one hand above the flame and one hand on the side of the flame.
Wow, I can feel a difference. The hand above the flame feels hotter. Why is that?
That's because the air gets heated by convection at the top of the flame. The air doesn't feel as hot on the sides, where there's no convection.
I see. So convection is when the hot air rises and the cooler air rushes in to replace it.
Exactly. And that's what happens in coastal areas too. During the day, the land heats up faster than the water, creating a sea breeze.
Interesting. So the windows in coastal houses are made to face the sea to catch the cooler air.
That's right. And at night, the reverse happens. Land cools down faster, creating a land breeze.
Wow, I didn't know that. So how does the heat from the sun reach us if there's no medium in space?
The heat from the sun reaches us through a process called radiation. It doesn't require a medium, unlike conduction and convection.
I see. So that's why we feel warm when we're out in the sun. And our bodies also give off and receive heat through radiation.
Exactly. Heat transfer by radiation is an important concept to understand. Let's